Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
Welcome to Speaking of Reliability. This is Dianna.
And this is Fred Schenkelberg.
Hey, Fred, I've been, I watch the news sometimes. And recently there was some news about fusion reaction.
Yeah, I heard that. It was, where we're recording, it was a couple of weeks ago or a week or so ago. But yeah, that was right out here in our neck of the woods at Livermore, at the Lawrence Livermore Berkeley. I don't know what the name of it is. It's a national lab, but they think they've been working on it for a long time. So it was kind of a major milestone for them to actually sustain a nuclear or initiate a fusion reaction.
Yeah, in a controlled way in order to be able to harness its energy, right?
Yep. And apparently they created about as much energy as they put into it. So but it was a milestone. They got energy out.
Yeah, but I heard a little bit more, but it sounded promising. And, a lot of the people in my circles, they've not been watching the news that often for various reasons. And when this hit the news channel, a lot of my friends hadn't heard of it. And they didn't talk about it at my kids' school either, because they're in middle school and high school.
Mm-hmm.
When I hear of news like this, I get excited because I start to tell my family and my kids about like this fusion breakthrough. And then also we watch some of the first rocket launches. And we watch those, and I always watch them with a sense of excitement. I think that helps get them excited about it.
Mm-hmm.
We start thinking about all the ways these new technologies, how they can affect our lives in the future, as far as travel and how we get our energy. And so we sort of start dreaming about what the future could be. Like I think of, I'm in the United States, that maybe with these rockets, I could travel to Australia in a matter of 2 hours, or we might be able to, launch from the moon out to somewhere else. And that's a dream that a lot of other scientists are working toward and experimenting toward. But I get excited with the idea of all these new technologies that are coming up, just as an engineer thinking about it.
Well, I mean, years ago when I was working with Hewlett-Packard, I was at one of the labs and they were working on using inkjet technology, which at the time we basically printed ink onto paper and we're getting pretty good at it. And they were printing other materials and they were trying to print circuit boards, print the capacitor built into the board or print a resistor into the board. And so what do you call this thing? And they're showing me these early mock-ups and prototypes and some of the samples they were printing. And they go, we call it a replicator.
That sounds like something from Star Trek.
It is. And, simultaneously, it was about the time that cell phones were just getting started, the flip phones and stuff like that, and BlackBerry. And they were expensive, but for me doing business travel all the time, I got unplugged from my home phone. I didn't have a landline. It was another realm of magic that in the 60s, these science fiction writers were saying, oh, you could have this little device, you flip it open, you could talk to anybody or anywhere in the world and they can talk to you. The tricorders or the medical devices, scanning systems, where other science fiction authors, Jules Verne said, we're going to fly to the moon. I don't think they actually got those people back, but
his book, yeah.
But that was in the 1800s. In submarines, they were, talking about these nuclear powered submarines back in the 1800s. And, but I heard it in a podcast by Seth Godin in his podcast Akimbo, where he talked about the pace of innovation is outstripped our culture's interest. He was kind of like, yeah, they just landed a rocket, they took this rocket off and they landed the main base of it on a platform next to where they're going to launch it again next month, and there was like, But I'm with you. I watched that. I was excited, especially because I knew that the first 3 of them were going to crash or whatever. And that was exciting. It's like, how are they going to solve that? How are they going to solve? And they did. They got pretty consistently good at it now. It's amazing. But that sense of wonder is evaporating in all kinds of different reasons. But part of it is that we don't have 3 stations to watch where it's the science network makes the news. Basically, it's
too much information. Yeah.
Well, it's also too much. It's too much. What did Elon do this week, or what's the new fashion trend, and how did this superstar get in trouble, and who married who? It's like, who cares? That's been around a lot too.
Yeah, that's been since the beginning of time
Yeah.
and humanity. Yeah. But this news, like I mentioned earlier, a lot of my friends, family, neighbors, they didn't hear about it.
Mm-hmm.
And kind of, I mean, it hit the news as a blip for a second. And I don't know. Maybe people aren't looking for this kind of stuff, or maybe it's because we're engineers and a little bit nerdy. we kind of latch on to, wow, what's that about?
Well, I think
I'm not sure.
Well, I don't know how long ago. I'll have to look back in the list. But is one of the podcasts was about what makes reliability engineers unique, and I think it applies to any engineer. Is this curiosity? But I think it's more perverse than that. And I'm thinking of, what are all the ways that this can fail? We just invented this wicked new cool gee whiz thing, and nuclear fusion it opens up so many things that are possible for creating that power and not polluting and all other benefits it can have. And it's a long ways off still, but it's worth dreaming about. But then on the other hand, how would you like to be the engineer that's making sure that it works and doesn't fail? And if you saw a picture of that thing, it's like, there's a lot of moving parts here.
Yeah, I saw one picture of the facility, and it looked really complicated. It did.
It's amazing technology. And I mean, it's even like the particle accelerators, which have been around for, decades and decades, and all the magnets have to fire in millisecond timing or even faster than that. And it is the number of parts and connections and wires and circuit boards and software and all the other stuff that goes into it, and go, oh, I forgot to tighten that bolt. Whoops. And now, a $20 million experiment is worthless. So part of it is, when I look at it as job security for reliability, is if you invent something new, you've just invented 20 different ways it can fail that we didn't know about before. I often joke, and I think I've said it a few times recently on the show, is that it makes it hard to get on an airplane. If all the ways it cannot work, even though I know from all the data and all the information, everything else, that getting on an airplane or a rocket go 2 hours to Australia from New York is probably safer than getting to the airport or the launch pad.
Yeah, but it is a complicated system.
Mm-hmm.
But you have more control over the one contained system than everybody else driving on the road to get to the airport, right?
Well, it is a system. It's in chaotic flow sometimes, but it is a system. Yeah. So, the self-driving cars and smart cars that, basically know where everything's around them, and everybody can go 90 miles an hour, but 3 feet apart, and it's quick enough reactions that you don't have to worry about it. That one I'm a little worried about. But it's, I think that the evolution of technology has got, I think what you're mentioning, Dianna, is that people are just not curious or aware of it, or it's not presented to us in a way that makes an impression. But the hard part is if you start doing that, as we know, it's every day. If you paid attention to scientific journals and to, it's just every single day. There's hundreds of new breakthroughs in one field or another. It's exhausting to keep up with it all. I heard years ago that there were more scientists alive and working on inventing things today than all of history, like from before 1950 or something.
Oh,
like
really?
That. Yeah, there was more. Well, one, there's a lot more people, which presents its own series of problems.
Yeah.
But a lot of them are well-educated scientists and engineers creating stuff. But there's more alive. I think it was in 1990 or year 2000. There's more alive working on this stuff than there were all time combined up to 1950 or something like that. It was one of those kind of amazing statistics. And I'm like, how do they know that?
Well, so there are more people inventing new things. And as you mentioned, it's an exponential growth of new inventions and new ideas, and that there are new ways to fail. So that kind of compounds the acceleration of how fast we're developing things. It's like, hey, we did this. It's not very reliable. These are the ways that it fails, or this is what could be better with it. And so it sort of necessitates the invention of new things too.
Oh, yeah.
Yeah.
No, it's part of the progress. I mean, in any product development, any system development, at first it's a disaster. I mean, it's not perfect to start with. And then we make it better. And so it's part and parcel to why I say it's job security for us. Somebody comes up with a brand new novel idea, which off the top of my head, I don't know of any because I think a good number of them have been taken.
Yeah. There's nothing new going on.
Well, it is more difficult. There's,
Yes.
Can you imagine doing a PhD thesis nowadays and you have to do something new? It's like, what's left?
That would be interesting to look into, Fred. I might look into that. What are people doing their thesis on now? But anyway.
Oh, well, my she's in a PhD program, by the way, and she's working on, in layman's terms from the chemistry, she's making a small cage to contain a particular type of nucleoid or something like that in order to dramatically increase some reaction rate. But it's a physical structure that they make chemically at the atomic level. And it's like, is this like a mini buckyball? And she goes, yeah, pretty much.
Oh, wow.
And I'm like, and what's it for? And then she went off the deep end in chemical speak. And this poor physicist couldn't keep up. But it sounded pretty cool. So, but there's stuff on every edge. And I think part of it is exactly what you just mentioned, is that we create this idea. We want to use rockets to travel across the world in a couple hours, or even just the space. There's enough people that just want to get out of orbit. And that presents all kinds of challenges. We got to invent this and solve that and fix that. And yeah, no, it's just amazing to me. I mean, can you imagine a plane load or a rocket with 150 people on it and with all walks of life? You don't have to get a physical to get on the thing. And then all the vibration and noise and acceleration that you have to withstand to get there. And by the way, I want to make sure my coffee doesn't spill when takeoff.
Yeah. What snacks are being offered on this flight?
That's right. Do they have time to serve your dinner? I mean, why go if they're not doing dinner? Oh, there's another problem, just scheduling. If you take off at New York and land in Sydney, now it's 12 hours difference or whatever the time difference is. They say you're going all the way around 12-hour jump in 2 hours. Does that mean you get there in time for dessert? No, it's 12 o'clock in the morning. It's, take off at 6 at night and it's 6 in the morning. So do you serve dinner on the plane or breakfast?
Yeah. I don't think I would care about that though. If I could get to Australia in 2 hours, I mean, like I would deal with whatever, time lag I had to deal with.
Well, you probably complain if you got a bag of peanuts that were stale. Come on. those pressed,
You're right.
pressed
I spilled
food
my
things.
coffee and the peanuts were bad.
And we didn't have enough time for the movie.
Yeah. Yeah.
It's amazing to me is all of those things we're mentioning were just unfathomable 50, 75 years ago. It's just, you're going to get on a plane and watch a movie. Now we're thinking about, well, how come we don't have 5G on the plane yet?
Yeah.
Yeah.
Or I want more than one option for a movie.
That's right. Yeah. Well, now they make you carry your own device to watch your own movie. You bring it on with you. But it's the pace of invention, I think, just quadruples the pace of things failing. And one of the things that fascinates me about it, and I've talked about it a couple of times on the show, it was a question I got a couple months ago now. We're working on this new product. It's got some new technology, but a lot of circuit board and polymers and an enclosure and a power supply and stuff like that. What are all the ways that this can fail? Is there a listing of failure mechanisms that we can make sure that we're covering everything? No. There's, grand generalizations. There's corrosion and there's contamination and then there's, poor manufacturing. There's this, that, and the other thing. But that's not what you're looking at. No, it's like in corrosion. And I think the point of it is to say, if you're not aware of galvanic corrosion and cavitation type pitting as a type of corrosion, or just oxidation or UV radiation caused degradation. If you're not aware of all these different things, how do you know to go look for them? Now you compound that when you say, all right, here's this really cool material that we've never used before, and we think it'll be useful for this application. And then it's like, well, how does it not work? And because it might create a whole new classification of a type of corrosion that, for example, if you take very pure lead or very pure tin, it has to be very, very pure tin. And I'm drawing a complete blank on the name of it, but it will turn into a white powder under the right conditions. It's a type of corrosion, but it only occurs with pure tin. It just goes to powder. It just loses all integrity as a metal. It's still metal, but it's powder form. I think somebody will know the name of that. But if you didn't know that and you're thinking, we can use this tin plating on this and make it really pure, it gives us better machining capabilities, blah, 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 and then wonder why in 2 weeks or 2 months that it just falls apart in your application. It's like, you need to be aware of these things. The trouble is when it's brand new, nobody's ever purified tin to that level before. And then it's like, why is it doing this? That's the fun part, I think. That's even more fascinating than flying to Australia. It's like, meh. What are you going to Australia for anyway? Is it for like a tennis match or something?
No, I don't know. My husband went on a trip there, and it was like the best place he's ever traveled to. He loved it.
That's cool.
Loved the people and the culture and
they almost speak English.
Yeah, close enough. You don't have to worry too much about taking a translator book or a quick lesson before you go, I guess.
Well, we could make a whole episode about the problems with that, but
I don't know if reliability engineers are the right ones to talk about that.
No, probably not. But, do you get what the idea is that, if you create something new, it's really wonderful and we get opened up this new opportunities and everything else. But there's always somebody like Fred sitting there going, well, how's it going to break? And I think the more effective we are at doing that, the quicker we get that thing, the new invention or whatever, into service in a meaningful way. So I think that's part of why I say it's job satisfaction when you do it, but it's also job security because we're constantly inventing new stuff, we being the world in general.
Yeah. Yeah. And then, you don't have to wait for failures to happen either, which is part of the reliability engineering is you can study it or to make it fail, see how it'll fail. And if you're creating that, like the new pure tin material, if you're the one that's producing it, manufacturing it for other people, then it would be good for you to understand what its limitations are. So then you could be a partner for other people to be able to use it in whatever application that they're trying to develop.
Which, there's a whole nother topic here. Is I remember talking to a vendor once, and it says, well, how does it fail? And it says, well, how are you using it? And I realized that matters. And I said, well, why don't you have like a characterization of this? What are the boundaries? He says, we don't know how people are using this. This is a discrete component sold at bulk to manufacturers that, selling it to Foxconn or somebody like that, and truckloads of it. And they're making 200 different products with it that go into 800 different conditions. We don't know how these things are actually used. We know it adds a little bit of capacitance or inductance to your system, as a component does, but we don't know where it is or how it's used or what stresses are under. And we can say if you step on it with a large hammer, it's going to fail. But short of that, we gave up trying to figure out all the application boundaries.
But they would know some, right?
Oh yeah, they know that if you blast it with an electron microscope or with a 4,000 volts, very quickly, yeah, it'll break it. But will it last for 5 years if you hit it with 100-volt pulses? Maybe. Depends on the temperature, how much humidity it has, what other oscillations is it seeing, what's thermal cycling going on. And you can see very quickly that it spirals out of control with the number of permutations of stresses that could be applied.
And then we talked previously too that it is application specific. And then the companies that are building these new applications, they aren't, they don't want to share how their products fail.
Right.
they don't want to report that or share that out. So that does make it, that does slow the pace of innovation, right?
Well, it puts a damper on it, because if I knew that if you're my competitor and you're working on a new device and you ran into these 6 problems and I know about it, then I have it leg up. I don't have to discover them myself. I can learn from that. And I think that was the theory in the medical industry, is that of the reporting of stuff. And people go to great lengths to avoid ever having to report anything. So if they find something, they don't go to production. They keep that trade secret as long as they possibly can. It's like, well, whatever. I know Kirk loves talking about that. People don't share what they know.
Oh, really?
Yeah. That might be another reason to do the failure mechanism listings, is get an awareness of all these tin pest. That's the name of it. PEST. I think it stands for something, but that's that tin phenomena, tin pest. For your entertaining reading while you sit next to the fire, on the airplane.
Eating peanuts.
That's right. But it's part of this whole wonder, excitement, and everything else. And unfortunately, or maybe fortunately, I enjoy how things fail. Because it's the science and technology and the chemistry of it all is just phenomenal, how this stuff happens. And I'm glad there's people out there that like to try to make things that work, so that I get new ways to figure out how they don't.
It's a symbiotic relationship.
It really is. It really is. So hopefully the fusion thing will pan out. I know I heard that news and read up a couple articles on it, and we're like, this is cool. This is way cool. And yeah, not everybody does that, but I think the more you do it, I think it just enriches our life. I don't know of any really good science fiction stories now that have what's after a tricorder or a replicator, kind of thing.
They're more to do with AI, applications for AI.
Yeah, Arthur C. Clarke did that already. Robot. He didn't call
I
it
am robot.
Yeah. It's been done. So anyway, if you're listening to this and going, what in the world are you guys talking about? It's part of it is the wonder of the science and the magic that's going on around us. And part of that is, from our point of view, is then it increases the ways things can fail. We can actually do a lot of things to help bring new technology, new ideas to market by assisting with getting it to work and figuring out the ways it can be created such that it actually works. And that's a lot of fun. But also there's just so much stuff out there to be aware of and be conscious of. So if you're listening to this and you've got some ideas or some other miracle or science and technology that others should be aware of, let us know. Head over to accendoreliability.com/go/SOR and let us know what's on the plate. What do you see out there? What's giving you that sense of wonder, especially if it's a cool failure mechanism we all should be aware of. And you can find Dianna and I and the other hosts on LinkedIn and on our About pages. So plenty of ways for you to get in touch with us. And we continue to get questions and comments and stuff like that. And that, I think, helps make the show what it is, because we get all kinds of cool stuff to chat about that you care about in the audience. So, Dianna, when do you think we're going to get the next breakthrough on fusion? You got a prediction for that?
I think within the next year, there'll be some incremental step that we'll have to search for the news article for.
Yeah, unfortunately. I'm going to set up a Google search for that, just have it standing. That's a cool technique.
That's a good idea. Yeah, I never thought about that.
Yeah. No, it's pretty cool. You have to sift through it a bit, but that will be one way to keep up with it, the topics you're interested in.
Or maybe they even have a social site where they might give their press releases. I have to check that out too.
Oh, let me know if you find that. That'd be cool.
Okay.
All right, cool. Well, thanks so much for bringing that up. It was, and I think will continue to be, a pivotal moment in how we create energy. And so I'm looking forward to how it'll break.
Me too.
All right. Thanks, Dianna. We'll talk to you soon.
Thanks, Fred. Always a pleasure.
Cheers. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.